Hey everyone, and welcome to The Explainer. Today we're diving right into one of the absolute biggest hurdles in the tech world right now, moving AI out of that flashy, super cool demo phase and into scalable, reliable enterprise reality. Because let's be honest, AI adoption almost never fails because of a lack of good ideas. It fails because the road from a really successful pilot program to a rock-solid production system is just, well, it's incredibly murky.
Look, enterprises aren't asking if they should deploy AI anymore, right? That decision is entirely in the rearview mirror. The question that's actually keeping CTOs up at night is a whole lot tougher. It's how in the world do we balance rapid AI innovation with strict operational realities? How do we safely deploy this stuff at scale without shattering our existing infrastructure, violating data governance, or just totally blowing up the budget?
So here's our roadmap for today. We'll quickly run through the AI production gap, unpack RAG using a really helpful library analogy, look at the IBM Fusion Foundation, map out scaling from pilot to production, touch on accelerating data with AFM, and then wrap up with the bottom line.
All right, let's kick things off with Section 1, the AI production gap.
This is a deeply frustrating reality, and you've probably seen it firsthand. You build a fantastic chatbot, right? A handful of users test it, they absolutely love it, and then it just hits a brick wall. It never actually makes it into the daily enterprise workflow. So why do so many of these successful proof of concepts just stall out right at the finish line?
Well, there's a massive tug of war happening. On one side, your dev and business teams want to experiment quickly. They want the newest AI assistants deployed, like yesterday. But on the other side, leadership is demanding measurable business value, ironclad data governance, and predictable costs. And honestly, they absolutely refuse to commit to massive, unpredictable GPU-heavy architectures before real, widespread usage even exists. You can't really blame them.
Which brings us to Section 2, RAG, and the library analogy. This tension is exactly why we need to talk about RAG, or Retrieval Augmented Generation. RAG is brilliant because it delivers immediate AI value by grounding responses in your existing enterprise data. And here is the absolutely crucial business takeaway. It does this without retraining models. That is huge. It makes RAG the perfect first AI workload. It mitigates your model risk because there's no opaque black box tuning happening, and it completely locks down data risk because the system doesn't learn from user input. Your proprietary data stays entirely yours.
Think of your enterprise data like a massively well-organized library. You've got security guards, librarians, strict access rules, the whole 9 yards. The old way of doing AI was basically like building a totally separate shadow library, copying all your books over to it and trying to manage it independently. It was a messy, incredibly expensive governance nightmare. Modern RAG flips the script. It just acts as a data platform feature. You're simply adding an intelligent search function inside your existing secure library. The books don't move, your security rules stay perfectly intact, and the AI just safely reads from your single source of truth.
Let's move on to Section 3, the IBM Fusion Foundation.
Now we have to ground all these abstract software concepts in physical reality, right? Because AI inference doesn't just magically run in a vacuum. It runs right alongside your storage, your networks, and your security controls. Enter the hyper-converged IBM Fusion platform. This is the engineered, fully validated physical foundation that's designed specifically for trusted, on-premises AI deployments.
And IBM Fusion is not just a box of parts. It features fully integrated compute, lightning-fast NVMe storage, and networking, all wrapped in an OpenShift native deployment model with automated lifecycle management. This kind of engineered architecture radically reduces your operational risk and ensures that your data, your security, and your AI software stacks are evolving together, instead of acting like these disconnected, fragile systems. Plus, it supports a mix of CPU and optional GPU nodes, which gives you incredible, strictly cost-controlled flexibility.
And that flexibility leads to a really fascinating architectural reality, the CPU-first approach. You see, for a lot of enterprise RAG workloads, especially those using small language models, focusing purely on massive, insanely expensive GPUs is actually sort of misplaced. Generating AI tokens is inherently a memory-bound process. Every single generated word requires reading model weights from memory. So by routing inference directly to the CPU, you avoid massive over-engineering. You keep your infrastructure incredibly simple, and most importantly, your inference costs remain highly predictable.
Section 4, scaling from pilot to production.
A massive advantage of this IBM Fusion CPU-first architecture is that you absolutely do not have to overinvest on day one. You can scale in 3 very practical, logical stages. Step 1 is your proof of concept, let's say 10 concurrent users testing out a departmental chatbot. Step 2 is moving that pilot into production as usage naturally ticks up. And Step 3 is true enterprise growth. That's where you can seamlessly add optional GPU nodes to the exact same Fusion platform, but only if you start running much heavier workloads. You basically grow exactly at the pace of your business with zero regret.
The hardware evolution making this possible is genuinely incredible. Look at the exact same server footprint. The Intel Xeon 4th Gen handles around 14 to 18 concurrent users, with roughly 614 gigabytes per second of memory bandwidth. But when you move to the new Intel Xeon 6, memory bandwidth jumps by about 50%. And because RAG is memory-bound, like we talked about, this hardware upgrade effectively doubles your user capacity, now serving 28 to 40 concurrent users. And you haven't even changed your software architecture or added any new servers.
And the best part? Speed doesn't suffer at all as you scale up. On that Xeon 6 architecture, the time to first token, which is just how fast the AI actually starts typing its answer back to the user, is a blistering 1.5 seconds. That is well under the standard 3-second SLA most places use. It proves that the user experience stays absolutely phenomenal as your deployment grows, which guarantees user adoption won't drop off just because the system got laggy. Let's look at Section 5, Accelerated Data with AFM. So as you start scaling all this up, data gravity becomes a huge, heavy issue. Enter the optional Active File Management, or AFM, data accelerator nodes for IBM Fusion. Because as your AI needs to query more and more data spread across a sprawling hybrid cloud environment, you desperately need a way to access that information quickly without completely bogging down the network or making a million duplicate files. The business value of AFM here is just massive for enterprise growth. It supercharges your remote queries, it boosts S3 object stores, and it dramatically speeds up access to Azure Blob Storage. But perhaps most crucially of all, it eliminates data movement. You don't have to physically drag petabytes of data over to the AI. AFM simply caches and accelerates access remotely. This completely locks down your data governance, because you aren't making vulnerable shadow copies everywhere, all while keeping a strict lid on your storage and egress costs. Finally, Section 6, the bottom line. I want to really focus your attention on this quote directly from our source material. The difference is not whether the POC works today, but whether it keeps working when users show up tomorrow. Honestly, that hits the nail on the head. Almost any hardware can run a tiny, isolated demo. But true AI success, that is defined entirely by sustainable, governed scalability. With IBM Fusion and a really smart CPU-first RAG architecture, you aren't just barely surviving a proof of concept. You are intentionally building a platform designed for the hard reality of day 2 enterprise operations.
And that leaves us with one final, pretty provocative question to consider. Take a hard look at your own data centers and your current roadmaps. Is your infrastructure ready to scale without regret? Can you maintain strict data governance, ensure cost control, and actually deliver rapid AI value when user demand doubles or triples overnight? By utilizing tools like RAG, IBM Fusion, and AFM accelerators, the answer can be a definitive yes. Thanks so much for joining me on this explainer, and keep building smart.